proof of case 3, I'm sorry. Case 3. What's the assumption that I have on the angle? Greater than 90, strictly less than 180. Why would I say it's strictly less than 180? Why is it not allowed to be exactly 180? Yeah, because then I have a line and that's not a triangle, right? It's still valid, but I think it's useful not to get in that concept. Let's begin with a diagram. If it's obtuse, that means that I have this angle right here we call theta. And then we would call this thing across from theta, what's the one across from theta? C. And then maybe we call this one A and this one B. Did I do okay on that, Omer?
Yeah.
Was that your choice too? Cool. And then I move over this way, and I drop this thing down this way. And perhaps I call this right here H, and perhaps I call this thing right here X. What would this angle be right there?
180 minus theta.
Yeah, it would be pi minus theta. Right? Because the entire thing, the entire angle is, if I went from here all the way to there, what is that? Pi. But then I take away from pi this theta, right? Okay.
That was theta minus x.
X, what is x right here? X is the distance from this point to the point here. Could you guess what's true about this angle right there?
90.
Why would I require that to be 90? And in particular, let's do, here I'm going to make a claim. We have triangle 1, we have triangle 2, and then we have what we call trigonometry. Did I spell that right? God, that's a miracle. All right. Triangle 1, could you see the first triangle?
Which one are you referring to as the first triangle?
I mean, what's the easiest one?
Oh, the biggest triangle. Wait, oh.
Yeah, so what would we say? X squared plus h squared is equal to b squared. Okay, that's the first. I mean, I don't know which one you want to do, but that one's kind of pops out immediately. What about the other one? A plus x, because it's the entire distance, quantity squared plus h squared is equal to c squared. And that's, both of those are called what? But what's both of those instances of? Pythagorean theorem. Do you know why the Pythagorean theorem is true? Can you show it to yourself? Do you know a way to convince yourself that that must be true? At least one, right? Okay. Trigonometry. Let me ask you this. What do you know about the relationship between this and that? Okay. Cosine of pi minus theta is equal to what? X over b. What would that immediately imply about x?
That's equal to b times
Cosine of pi minus theta. Now I need to do some work. This is not the only trigonometric fact that I have to be aware of here. What do you know about the cosine of negative theta? And what I want to do is I don't know where I'm going to graph this. Maybe I'll graph it over here. Okay, I'm going to do 3 cosine curves. So I want to draft the cosine curve. And actually, I'm going to ask you to do this proprioceptively. I want you to do this using your hands and your body. It's important to bring body into mathematics. I really believe that, right? Okay, so what you're going to do is you're going to take your left arm and put it horizontally across your chest. And then you're going to take your right finger. This point is going to be the origin. Take your right finger and put that at the location of the cosine curve on that axis. Nope. Try again. Okay. Cosine curve. Cosine of 0. Here's the origin. Cosine of 0, what is it? 1. Must be up there. Now trace the cosine curve. Okay, so you got it, right? All right, so here we go. So there's the cosine curve. Okay, now I would like you to do cosine of negative theta. Don't trace it yet, just think about it for a second. What would happen if I go backwards on this curve? It's a mere reflection. In other words, cosine is an even function, which makes sense from the standpoint of Taylor series because the Taylor series approximation has all squares. 4th, 6th powers, blah, 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 right? So what's the cosine of negative theta? It's the same thing. Let me ask you this. What would happen if I shift the cosine by pi? If I shift the cosine of this thing by pi. And this one always tripped me up when I was a student. I never understood shifts with pluses. What does a plus do to the graph of a curve?
It makes everything happen earlier.
It makes everything, yeah, that's one way to say about it, yeah. I like that way of thinking about it. Can you wait on that one though? What does a plus do to the graph of a curve? If I added pi to theta, does it shift it right? It seems like it would shift it right? Why would it shift it left? Yeah, that's an open question. Can you mark that one for yourself? That one takes a while to think about. That took me, I think I didn't get that until I was really in calculus. And I had learned trigonometry like 2 years before I learned calculus. And I somehow got A's on those tests, and yet I didn't understand that. If you have a plus on the inside, I'm going to make a claim, it shifts the graph left. And the reason that it shifted left is that this actually gets into 1D material. It's not the same thing as measure theory and the concept of measuring sizes of inputs, but it is related to that because you're actually doing some very, very interesting, you're doing a shift in the input that actually makes you realize inputs sooner. The best way to think about this is, when would pi usually occur on this thing? And you could do that graphically. When does pi usually occur? Right here, right? But if I add theta to pi, when does pi occur in terms of theta? 0. So now I've taken this point and I've mapped it back over here. In other words, I've taken the input to my function and I've made that input happen sooner. Well, if I have the entire curve, when do inputs happen sooner? If I move the curve this way, the same input would happen later. If I move the curve this way, what would happen? Sooner. So what do I do when I add pi to this input? What do I do to that graph? I shift it left by how many units? Pi. So that means this graph, if I looked at this graph graphically, bad joke, it would look something like this. It must be like that.
So would it be the opposite then by your logic?
What is that equal to? The negative cosine of theta. Okay, what does that immediately mean about b? About x, I'm sorry. What must be true about x in that case? Negative b times cosine of theta. Anybody confused about why adding shifts things to the right, or the left, I'm sorry? You need to put that on something to study. That's something that is a prerequisite to this class. I don't care if it's a prerequisite. If we don't know it, the day we figure out we don't know it, we got to give attention to it. Pluses move stuff to the left. Addition moves stuff to the, subtraction moves stuff to the right. If you're not familiar with that, that's got to be part of the study of this proof. Yep.
Why did you write pi plus negative theta and not just plus theta?
Because I wanted to have this whole discussion, because so many of my students in 2B in the past, I've asked them what I consider to be a relatively easy question that's based on trigonometry, and they can't answer the question, why does addition move it to the left? And so I want to put you on notice today. This is your math education, and I expect that if you're in this class, that that's something that you know.
So by doing negative theta, you're actually taking theta to the right. Because you're
No, but I've just shown
for the second line.
Okay, so like the way that I'm thinking about this is the input to this function, right? And then I'm adding pi to that input. Yeah. I mean, you could call that gamma if you wanted to, and then you would be pi plus gamma, right? So whatever the graph of this thing is, I'd shift it pi units to the left, right? Yeah. All right. So we now have these operations. Should we do some work? Let's do some work. I need some space. Which one am I? I'm doing that one, right? Yeah. Yeah.
So you wrote cosine pi plus negative theta. Can you also write cosine pi minus positive theta?
Sure. But that's not the original input that we had, right? I'm asking you to target a specific weakness that I've seen in many of my 2B students. And that weakness is many of my 2B students cannot describe to themselves what the difference between adding something in the domain and subtracting something in the domain. Why, when we add, do you shift to the left? Why, when you subtract, do you shift to the right? And so what I'm saying is the input to this function, what's the input to that function?
Negative theta.
So just call that gamma.
Okay.
Okay.
So negative theta is.
So now, everywhere we see a negative theta, what are we going to call it? Gamma. So now I'm going to do what to gamma? I add pi. What's the result of that in the output space? What does that do to the range? What is the conjecture that Omar is saying or that I'm saying? I'm lying to you. Do not trust me. Do not trust my words. I am making a conjecture that could be blatantly false. In fact, I could be doing it on purpose. I could have malicious intent. Do not trust me. What's the conjecture that I'm making? That if I add pi to this input, what am I saying about the graph of that function?
You're shifting the cosine graph to the left by that many.
Would you bet your life on it?
No.
Until you get to a place in this course that you'd bet your life on that, do not trust me. I will tell you this, I would bet my life on that conjecture. I am certain of that conjecture because I've studied a very long time. Does it matter if I'm certain of something? Is that really what matters in math, that your teacher is certain of something? Does my knowledge have anything to do with your knowledge? If I'm presenting it and I help you learn, it does. But at the end of the day, just because I can present it, does that mean you know it? So what's my invitation to you? If this is a weakness, make sure that you understand that for yourself. It's part of this proof, and it's also a useful bit of information. Great question, by the way. I'm serious about this because I still do research in linear algebra. I'm writing a paper right now in linear algebra that's never been shown in the world before. It's something that I'm serious about. And what I've found from all researchers is I've never seen somebody that can produce math that does not understand every single thing that they're doing from multiple perspectives. This is the difference between getting an A in a class and making money using the material. You all claim when you sign up for a STEM major that you want to use math in your career, and the system is designed in such a way that you can get A's in all of your classes and not understand a single thing. Do you know how I know that's true? Because it happened to me. So I have a choice. I can recreate that system for you all, or I can show you a mirror maybe for the first time in your life and say, listen, you can do this. If I can do it, you can do it better. But make sure you understand this stuff, right? All right, what did we say about triangle 2? What was the Pythagorean theorem from triangle 2? A plus x squared plus h squared is equal to c squared. Can someone help me with some algebra there? A squared plus 2ax plus x squared plus h squared is equal to c squared. But we had this very beautiful relationship from triangle 1 that said that x squared plus h squared was equal to a squared. Sorry, what did you say? B squared, sorry, I didn't hear that. What else did we know about the letter x? Yeah, the letter x was negative b times the cosine of theta. Right now, I'm taking that on faith, right? If I don't understand that for myself, then this teacher could be lying through his teeth and I would not know. I'm claiming for myself, Jeff Anderson, I'm certain of this fact. I would bet my thumb on it, which is a really important finger, right? There's a lot of, my pinky doesn't do so much work for me, right? Because I don't have that big ring yet. Bling, bling. Every time I come around your city, bling, bling. Pinky ring, where the about 50, bling, bling. Lil Tucci, before he was Lil Tucci. What do you notice?
It looks like we've seen it before.
Yeah, so that's the proof of the law of cosines via the obtuse hypothesis, and then it relies on a little bit of cool trigonometry, right?